Continuous integration is perceived as a very scary idea by some, because it can be very far removed from how they are currently working. It's also widely misunderstood. Everybody has a CI/CD pipeline nowadays, right? Everybody has a continuous integration pipeline. Actually, no. For people unfamiliar with the definition, it can sound like crazy talk. Committing directly to the main branch, committing multiple times per hour, pushing those commits. In this video, I'll dive into the why, what, and how of continuous integration, and I'll answer common questions and objections at the end. Let's get into it. Part 1. Divergence is slowing you down. Continuous integration is about having as little divergence as possible. I'll explain throughout this video what this means. People using feature branches often integrate only a few times per week or per sprint. Integrating being your code being merged to the main branch and your code running amongst the other code that is being developed. When you integrate to the main branch that little, it takes a lot of time to integrate. You get problems like merge hell and having to wait a very long time for code reviews. This all slows you down as a team. It postpones the detection of problems. Have you ran in the right direction with your feature branch? Are you making the right choices along the way? You are having very little moments of check-in. Having a separate branch where your code lives means you're running into a different direction than the others. The longer you run into a different direction, the more time it will cost to get back together. This is divergence. Continuous integration tries to minimize this divergence. Continuous integration says integrate as often as possible. And integration means having your commit on the main branch. Integrating very often means you get a very short feedback loop. You get feedback all the time on whether your code will work together with the code that's already there. You get feedback on whether you're all moving in the right direction. Not diverging means you're having less integration conflicts, less merge hell. Less errors and bugs even, because you take on less risk. The risk being that you've run too far in the wrong direction and need to backtrack. And backtrack, to be very clear, means deleting code. It means starting over for part or all of it, because you have taken the wrong turn, so to say. Now the conflicts are not gone, the conflicts are just fed to you bite-sized. They're really small steps you can easily solve and you can easily talk about. In the end, software engineering is the practice of exploration together with the team to figure out what direction you should be going with the codebase to solve the problem at hand. Making a mistake is a good thing, that's part of the process. But now making mistakes is very cheap, it's very fast, and we can learn very fast. Again, every time you make a mistake, you learn. That's what we're doing. Shortening the feedback loop makes us quicker as a team. The longer you have a branch open, the more your code diverges from the rest of the code. We need to shorten the time we're running into different directions, and CI does exactly that. So continuous integration is the opposite of having feature branches? Yes, by definition. Because having your code live in a feature branch means you're isolating your change. Isolation is the opposite of integration. Part 2. What is continuous integration? Continuous integration is often misunderstood as being about tooling or about the build server that you have. This is wrong. Continuous integration was conceived of in the 90s with extreme programming. It's currently defined as the practice of merging all the developers' working copies to a shared mainline several times per day. And merging or integrating is defined as either committing to the main branch directly or merging a feature branch that has lived very shortly. Very shortly being minutes or maybe an hour, not days or a week. So the logical conclusion is that you don't branch. Everybody just commits and pushes to the main branch. And this commit happens multiple times per hour, at least multiple times per day. And every commit is immediately a push so that your code is running amongst the other code. The DevOps handbook calls this trunk-based development. Trunk being the main branch that you're committing to. And this may sound far-fetched, but it's actually easier than you think. It takes very little time to get used to. If you don't add at least one commit per day to the main branch, you're not doing continuous integration. It doesn't qualify as meeting the definition of continuous integration. So a strategy like Git flow or feature branches, having long-lived branches in general, is not continuous integration either. Your code needs to run among the other code. It needs to be integrated. Actually integrating means having your commit on the main and everybody else's commits to main as well. Continuous integration is made a lot easier by having a build server that runs your automated tests every time you add a commit. For every commit, it will run all the tests and it will give feedback in a quick and clear, concise way. It's either red or green, nothing in between, right? It works or it doesn't. And the moment you have pushed something, you get immediate feedback. So why does this work? You'll still have the conflicts, but then in much smaller steps. It's because you have communication about those conflicts. You immediately get feedback both from your build server and from your peers. Like if it breaks their code, then you also get feedback from them, directly or indirectly. You are diverging this way, they are diverging that way. Okay, let's take one step back. It's a tiny step we've taken, so it's easy to take that step back. We're learning quicker as a group. CI makes you communicate more often about the changes you're all making, and this communication solves the problem. This makes you diverge less. Part 3. Common questions and problems. Number 1. The feature I'm working on takes multiple days. Okay, sure, maybe true, but that's not a problem. You just need to lose the assumption that one feature equals one commit. You could easily split it up into 20 or more commits if that takes multiple days. Next. My code isn't in a workable state to merge to main that much. Maybe not right now, but it could be. TDD exists for exactly this reason. Test-driven development has the red-green refactor loop. Every time you have had one of these loops, you end up in a workable state. The feature isn't done, but it still leaves the code in a workable state. There's a difference between being done with a feature, which is a group of commits, and having a broken in-between situation. You don't have to have broken code in between. Committing features that aren't done is expected. It's part of continuous integration. You just have to manage this. And feature flags is one famous way of managing this. The creation of this feature requires breaking another feature. It doesn't have to. There's techniques you can use. There's things you can do to make sure these two branches of code, not literally branches in version control, these two implementations live next to each other, side by side, without conflicting each other. Feature branches and dark launching come to mind again. Working this way is a less risky way to move from implementation A to implementation B, just doing it gradually, while taking many small steps with as little risk as possible. But then code reviews need to happen multiple times per day. Yeah, that, or more pair programming. I really believe that you can do code reviews, but you should stay away when doing continuous integration. You should stay away from having merge requests or pull requests. That's a system that is designed for open source. It's a very slow process and it works very well in a no-trust environment. I've talked a lot about code review on this channel. I believe in the two-part code review, talking about code, talking about your solution design, this either face-to-face with your video on if you're doing it remote, or literally behind the same computer, but talking about the solution direction, about the quality metrics, like which separation of concerns you picked, why you picked this kind of coupling, why this is tight coupled, loose coupled, why these abstractions and interfaces. That is the important part, the talking about code. Then the line-by-line review that you do by yourself is the part, I would say in a CI environment, that you can skip. You don't need this merge request anymore. The moment you start pair programming, you don't need all of this because you're doing this solutioning together. But if you don't do pair programming in a continuous integration environment, then I would recommend to do a face-to-face code review only. And this can take 5 or 10 minutes, and that's it, that's enough. That's all the quality it needs. But to be clear, I would recommend less code reviews and a lot more pair programming. In fact, as much as you can handle as a team. Pair programming can take a lot of energy and focus. It can be draining. That's the one disadvantage of pair programming I can think of. But it does create value of having this shared direction. You're not running by yourself in a direction anymore. You're doing this as a team. You're doing this as a pair of people. So how much can you handle? How much can you handle as an individual? And can you handle as a team? Can you start with twice 1 hour a day in different parts of the day? 3 times, 4 times 1 hour per day? As much as you can handle, you should, because that is the way to do continuous integration. Next one. My build server takes an hour to run, build and tests. This is unacceptable for Velocity, whether you're doing continuous integration or not. You need to start investing considerable time to speed it up. A quick feedback loop starts with a super fast build. I would recommend using a performance budget of 10 minutes. Your build needs to take less than 10 minutes. If it isn't taking less than 10 minutes, you start spending time to optimize it, to take it down to beneath the 10-minute mark. The moment it is beneath the 10-minute mark, you don't spend any minutes optimizing it further. That's what a performance budget is for. I think 10 minutes is a reasonable number for a build. Next, but then we're deploying features which aren't done. Yes, that's the point. And while it may feel scary right now, it's actually proven to be less risky. This makes you ready to go and aim for continuous deployment, continuous delivery after this. It allows us to release quicker to users. This is what we're aiming for. This is what we're paid for as software engineers, to deliver value and to do that as quick as possible. Last question. So how do I start? First, get the basics right. Make sure everybody is in version control. Make sure you can run tests locally. Make sure you have unit tests and integration tests. Make sure you have a build server that builds every commit that is pushed to the main branch and that tests are automatically run for every commit that is added to it. Make sure the build server reports clearly on whether the build has succeeded or failed. No in-betweens, it's red or green. Then make sure your build server runs fast. Fast means less than 10 minutes. And then you can start investing in skills like test-driven development and pair programming, both vital to having successful continuous integration. Make sure every commit includes the tests. TDD will help you make your code so small that you can commit multiple times per hour and it includes the test. That is what it was designed for. And if code reviews are slowing you down, move to more pair programming. That again is what it was designed for. A pair programming replaces doing code reviews. And lastly, you need to create rules to work together as a team. Now that you're all committing to this main branch, you're integrating more often. It also means frustrations can come up. And this main branch needs to be green all the time on the build server. It means if you push something, you might want to have this rule in place that you need to watch the build, whether it's going to be green or red. And the moment it's red, you need to immediately push a revert commit so that you're not blocking the others. The others can move on. Committing to fixing problems immediately and also committing as a group to keeping the build fast. And every time it is above this 10-minute mark, for example, if that's the bar you pick, then you should immediately start spending time to fix it and find the thing that slowed it down. To summarize, continuous integration is a necessary step if you want to start releasing more often. If you want to move to continuous delivery, continuous integration must happen first. You cannot do continuous delivery without having continuous integration first. Continuous integration is especially recommended if you're dealing with very large commits, if you're dealing with large merge requests, if you're dealing with lots of merge conflicts, or if you're dealing with lots of waiting time on code reviews. In addition, continuous integration pairs really well with test-driven development and pair programming. Test-driven development because it leaves your code in an always workable state, and pair programming because it makes code reviews unnecessary and thus can speed you up. And lastly, continuous integration will help you develop the capability of being able to deploy to production without releasing to users. Techniques like dark launching and feature flags come to mind. And that's it. I hope you liked it. I hope this was useful. If you have any thoughts or if you have a request for a future video, please let me know in the comments and subscribe. Thank you very much for watching.